name is Priya. So I work on the junior project. So I try to keep my team on the track and on the deadline. And also I did the installations part for the server oven. And I did the circuit simulations using the ATSPICE software. Thank you.
I'm Nicholas Portlow, and I worked on the general assembly of the project. I took drilled holes into parts of this oven to fit the new components that we added, and cut open holes so that it can for the fans in the back, so we can control the heat, and also helped with the insulation.
I'm Stefan Folsing, and I worked on circuit design.
Hi, I'm Marcus De La Garza, and I was in charge of the programming and the perf board construction. So here we have a toaster oven that we've converted into a reflow oven. So if you'll come close here, we can see that right now it is in the preheat stage. That gets it to the point where there's enough heat within the oven that it won't take forever to start up. So I'm going to go ahead and press this button here, which will start the reflow curve. So it's in the preheat phase right now. That brings it up to a certain temperature. Then it will do the soak, where it will maintain a temperature. Then the reflow, which is where it will basically get as hot as possible to melt the solder. And then it will enter the cooling phase, where it will cool everything off. So here we have an LCD that displays the current phase that the reflow curve is on, as well as the current temperature. There are 3 thermocouples within the device in 3 different spots, and we take the average temperature between the 3 to get a more accurate reading. I have a MOSFET here, which is controlling 2 fans in the back of the unit. They're 12-volt fans, and the microcontroller is a 3.3 volt device, so that's why we're using the MOSFET. In here is the Raspberry Pi Pico, which is the microcontroller that we decided to use, and it is outputting serial UART data to my computer here, and we're getting a live read of the temperature. So if you take a look in here, you can see that the heating elements are on. It just turned off, so you can see the power light went off because we have entered the soak phase. This is where it will try and maintain a temperature. It won't do it perfectly because even when you turn the heating elements off, there's still a lot of heat in there that will make the temperature rise. But over time, you'll see it start to level out. So it will maintain, or attempt to maintain, this temperature for a while. After that point, we'll enter the reflow stage, which is where the temperature will ramp back up again. So I've got 3 buttons here. The first one enters that preheat, which is what you would do before you put the board in. The second button enters the main reflow curve, and the final button just turns everything off, sort of an emergency stop. As you can see on the curve here, it's starting to level out, which is what we wanted to see. And eventually it will hit the reflow stage and everything will turn back on again. I've also got a external 12-volt supply here, which is what's powering the microcontroller through a buck converter, as well as the fans that run on 12 volt. So we just hit the reflow phase, so the oven turned back on, and so after a certain amount of time we should see the temperature begin to rise again. It looks like it is starting to rise.
Literally going over it with someone else.
that made an amplifier. This thing made their own amplifier. If it has noise in it.
So after it reaches the peak, it will hit the cooling phase and it will turn the fans on and attempt to cool the unit as fast as possible. All the fans are at full speed. We considered doing pulse width modulation control of the fans, but we determined that in order for them to cool efficiently, they would have to be at full speed the whole time. So it has entered the cooling phase, so the fans kicked on. So we should see the temperature start to decrease, which it seems to be doing.
This is such a large
Right, I can't see shit.
Yeah, he told us that was
All right, so you can see it's cooling, and it will continue to cool. And ideally, you would probably also open the oven door just to cool faster.
Yeah.
But that's about it. That's the demonstration of the unit.
Hi, my name is Maria. So I work on the junior project track. So I tried to keep my team on the track and then on the lead line. And also I did the installation part of the circuit open. And then I did the circuit simulations using the AT-Spice software. Thank you.
I'm Nicholas Portlow, and I worked on the general assembly of the project. I took drilled holes into parts of this oven to fit the new components that we added, and cut open holes so that it can, for the fans in the back, so we can control the heat, and also helped with the insulation.
I'm Stefan Falsing and I worked on circuit design.